Hey everybody, this is Larry. This is day 29 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Let me also check for the extra points. Okay, no extra coins. And also, there'll be the premium problem later, so definitely hit the subscribe button and also just click on that video, I guess, to watch it. Okay, so today's problem is 1697, checking existence of edge length limited paths. I'm gonna sneeze real quick, or half sneezing, so I don't know what I'm doing, but man, allergies this entire month has been kicking my butt. Sorry friends, we'll see. I'm still half sneezed, but it's the worst. But yeah, okay, let's take a look. What does this actually mean? An undirected graph of n nodes is divided by edge lists. Okay, so you have UV and distance, and an edge between UV and distance. Note that there may be multiple edges between two nodes. Okay. Given array queries where query sub j is equal to p, q, and limit, what is p and q? Whether there's a path between p and q such that, okay, so it's Boolean. Okay, I mean, I think I looked at a similar problem the other day, but it was online, right? And what I mean by online is that you actually have to answer the query. And the solution to that one is very funky, and I didn't really get around to implementing it because I was lazy, because it required LCA and binary lifting, and if those things don't mean anything to you, that's fine, because it is ridiculous to learn, to be honest. If you ask me for about like pretty much anybody, unless you're like doing really like, if you're good at everything else that we talk about on this channel, then maybe look into it. But by the way, LCA and binary lifting and stuff like this is just a ridiculous solution on the minimum spanning tree or something like this. But in any case, for this one, though that said that the actual live version of this with queries is absolutely ridiculous. But this particular problem though is tractable, but it's also a little bit weird in the sense that you have to take advantage of the fact that you have a list of queries, but you don't have to answer them in real time. And what I mean by that is that not only you don't have to answer them in real time, you don't have to answer them in order, right? I mean, of course, maybe you have to, for the actual answer, you have to put them, corresponding to the order of the query, but you don't actually have to solve them per query itself. And what I mean by that is that, you don't have to solve the first query and then the second queries and then the third query and so forth. You could do it in reverse order if you like. You could do it in jumping order anytime you like. So with all that said, this one I would say has a prerequisite of union find or disjoint set union. DSU? Yeah. So I would look up DSU, union find, and stuff like this. So this is, and maybe even, not maybe, but it, minimum spanning tree. Yeah, maybe minimum spanning tree, or just spanning trees in general, maybe, because this is a connectivity problem, right? So you don't really need the minimum part of it. Though this may resemble. The way that we're going to solve it is we are going to resemble Cusco, I think. Is it? I always... Oh, no, yeah, I think it's Cusco, right? Because I always confuse... Well, I don't confuse, but I just don't know... Well, I guess I am confused then. Which one is Cusco and which one is Prim? I almost said Prime, but Prim's spanning travel. They're both greedy in essence, so... yeah, so definitely these are things that kind of look into. There are probably, and well, not probably, most certainly easier problems on Leetcode to work on these skills so that you can get into it. I'm not gonna, I define these things as prerequisite because I don't want to spend that much time getting into these things, at least for today. Not gonna lie, it is Friday here. On the 29th, or this is day 29, but April 28th, and in 2022, is it 22? What year is this? Is this 23? Jeez, oh man, I lost a year apparently in front of you guys. But But what I mean is that the Warriors game is coming on soon, the NBA. So so I gotta go watch it afterwards. Definitely. Let me know if you're watching the NBA. Let me know in the comments which team you're rooting for, and why is it the Warriors. Anyway, so yeah, I'm not gonna go over DSU. It's like if you take an algo course in college or whatever, it's probably like a 2-week class maybe, or two not 2 weeks. But like 2 lecture class or something like this, depending on how deeply they go into it. There's ideas that I'm going to use, but I don't want to go over like from 0 to 1 because that's a little bit too much within the scope of this video. But yeah, so assuming you know where it is, and I think people, or a lot of people, if you're into the competitive scene, a lot of people do have templates for this, but I am going to do this template list, and I generally do, but maybe not. I generally do things template list because that's the point for me. Though lately I have a DSU template just because I don't know, people are getting way fast, and I need to catch up a little bit. At least during contest, I mean. Definitely, if you're doing it to practice for interviews, at the end of the day, you have to be able to do it, right? Okay, so let's set up. So the way that I think about DSU in general is basically a rooted tree, right? So you have these nodes. So in the beginning, you have a forest of nodes, and then as you kind of combine them, you kind of combine the trees such that they point at each other, and then the root of that tree is the representative of that tree, right? And then there's stuff like path compression and union by rank and all these things. I'm not gonna get into all the proofs and stuff, but I'm gonna just assume that they're all of 1 for the purpose of the huge inverse Ackermann function. If you really want to get into it, know that know that it's fine. I'm just lazy today, right? So yeah. So basically here, the way that I'm saying is that for each tree in the forest itself is the root, representative root, and then I have 2 functions, the union find, which is for find, and we just if parents of x is not x, then parents of x is equal to you find parents of x, otherwise return parents of x, right? So this is saying, this is almost like a memorization. I write it this way, it's a little bit confusing if you haven't seen it before, but the idea is that, okay, so is this the representative node, right? Meaning if you have a union find tree, is this the top node on the path in the tree? If it is not, then get the parent, right? Oh, actually, yeah, and then get the parent. You can, in theory, you would actually write something like if you really want to do it that way, you would do something like find a parent so that you can kind of get to the root of the tree, right? But the thing that the reason why I write it like this is that it kind of is memorization in that, okay, we recursively find the parent of the tree, so that you go up the tree to find the root of the tree, but then we save it down so that it path compression, right? I mean, if I'm doing a more in depth of this, maybe I'll draw a thing so that you can kind of see how it re-edges, but I'm not going to because, like I said, this is a prerequisite, but I'm just going over why I do this, right? Just very briefly, it is a Friday night, so have a little fun, right? So here we're trying to merge 2 trees. So UA is equal to, we find the root of A, we find the root of B, and then we just set parents of UA is equal to UB. There is a couple of things that I do here that I'm just lazy about, in that basically if you are able to visualize 2 independent trees in the forest, you could just look at the root of one of the nodes now pointing to the root of the other node, so that everything in that that is the children of that original tree will eventually, if you crawl up it, will now point to UB, right? So that's basically the idea. You can actually, the way that I actually, depending on the problem, but I am often very lazy because it doesn't provide too much benefit is that I don't do merge by rank or merge by size, merge by some function, right? It's just not usually necessary, but maybe I'm wrong, and maybe one day I'm gonna get bit by that. But I just kind of it doesn't really matter given random inputs. But sometimes if you are given specific inputs adversarially, then perhaps you can have a degenerate case. But there is this path compression, so in theory things get compressed in a very good way. Okay, so now all that is just to set up the union find. And then now what do we do, right? I didn't even go over the problem that much, to be honest. That's why I didn't want to spend too much time on union find. But the way we do it is that now, let's disconnect the entire graph, right? If we disconnect the entire graph with end nodes, and then for each edge, we kind of put them back into the tree one at a time. And in the order of the distance, right? Because then now you could kind of think about it as a graph that slowly builds itself up from small edges, and at the end of constructing all sorts of things, then we're able to answer queries in a very good way, right? Meaning that, for example, if we have a query that has a limit of say 20, another way to phrase it is process all the edges that are less than 20, right? And then after that, all we have to do is sort it in order so that all the events are processed in an interleaving kind of way, such that the invariant is true, where when you process a query, the current tree will be good enough, I guess, or it processes all the edges that are smaller with a distance edge or that are smaller than the limit, right? Okay. Okay. Yeah. Okay, so let's do that. Let's see, right? So for UV D in edge list, right? So the way that I always do it is have an adjacency list, but in this case we actually don't need a specific adjacency list. What we want is actually process these edges in order. So and there are a couple of ways you can do this. You can just have it, put it in an array, and then sort by that array with the sorting by distance. The way that I am doing it this time is actually having a bucket and then sorting that bucket so that you can process everything at the same time. And I'll show you what I mean by this in a second, right? So maybe I have something like edges is equal to collections.default, if I can spell correctly, of a list, and then now edges of D append UV, right? And of course this is bidirectional, so I believe so. Yeah, it should be. So yeah, I could just do it this way, right? And then we also want to do the same with queries. And you don't really need to do what I'm doing per se, but just for symmetry reasons, I'm going to do it this way. So for PQ limit in queries, QS of L dot append PQ, right? Oh, and we also actually, as we said, because we're basically destroying the ordering of the queries, but we have to return it in a certain order, so we need the index here. So then here, it doesn't matter where we put it, right? And then now we can proceed in order, and you can actually in theory merge these two lists, but I don't know, it's probably fine either way. But yeah, so then maybe I'm gonna do this a little bit lazily, but maybe I have qs.keys plus edges.keys, and the key in this case of course is the D and the distance and the limit together, right? So then now let's have a sorted version of this, and then now for I call it X because I don't know, I always think about things as a sweep line in this sense, and because it's a sweep line, I just call it X because you go from left to right? So you have all these events that are happening, and then you have all these things, right? So the thing that I'm looking for now is just double checking, and what I'm double checking is that it is asking for strictly less than, right? So given that it is strictly less than, then that means that we have to process the queries first given the same x, right? So then here we go if length of qs of x is greater than 0, that means that we have a query. Then for pq index in qs of x, we answered. Oh, we also need an answer thing, I guess. I think it's just none times n. I like using none instead of like true or false as a sender value, at least in debugging. Maybe when I submit, I would change this, but I have it as none so that if I don't set something, I don't fool myself that I set that index for, yeah. So here we have to process these, right? So then now it should be more straightforward, right? If you find a P is equal to you find of Q, that means that they have to both they have the same root, and if they have the same root, that means that they're in the same union find tree, and as a result, that means that they're connected. So that means that we can answer of index is equal to true. But of course, then, and if otherwise you set to false, which of course is just this this conditional, right? Okay. And then now we process the actual edges as well. So edges of x is greater than 0. The reason why I write it like this is because there may be a limit that doesn't exist in edge, and vice versa. And this, maybe I don't even need to write it like this, but it's fine, I think. And here, of course, you want to. You want to connect these two things, and that's how you do it. And that's pretty much it, really. And then at the end, just return answer, and this should be good. Okay, so apparently you can do it on these things. That's fine. I just have to convert them to lists, I think. Maybe that's a fair thing. I don't know, because I think these are what's it called? Like you can't swap them or whatever they call it. I forget what they call it. Did I mess this up? Oh, this is an N, this is Q, where Q is the number of queries, obviously. Still wrong. Did I do them in the wrong order? I write true, so 0 and 1 is 2. I'll put true, but I write false. That's weird, right? Let me double check something real quick. Usually I get this pretty right. Okay. Did I? The limit is right. Okay. Yeah. Let me see what's happening here. Just debugging. None. So 2, 2. So I set the same index twice. Why is that? So at 2 it sets it to false, which is correct. But then at 4, we don't have a query at 4. Did I mess this up? It may be that I just messed it up, but that's fine. Like, why is this twice showing up? Oh, I see. I see. I'm being a little bit silly, I think. The reason is because this is not unique. Yeah, okay. So I just have to convert this to reset. I'm not gonna lie, usually I don't write it this way, so that's probably why. Because it's not unique, it processed the same, it processed this thing twice, and that's why, right? Alright, let's give it a submit. Hopefully I don't have any more silly errors. And yep, there we go. 11-24 day streak. So what's the complexity here, right? As I said, for the purpose of this video, let's just say that these are all of 1, and for the purpose of this, for each element, right? This is O of n into the number of edges, O of y, if you will. This is O of q, and this is O of n log n, or y log e plus, y log e plus q log q, just for the sorting. Otherwise, everything is linear. So yeah, so this ultimately is going to be O of, let's just say n log n plus q log q time and O of n plus q space, right? For both the thing, and this is the O of q space, because that's the answer. You can't really avoid it. That's all I have for this one. That's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.